Welcome to the Hardware-Software Interface. My name is Gaetano Borriello.
And my name is Luis Sazzi.
And we're going to tell you a little bit about ourselves to start things off. I've been at UW since 1988. I have a PhD from UC Berkeley in computer science. And my hometown is Naples, Italy, where we're famous for wood-fired ovens that make delicious pizza. And I have a research trajectory that's taken me through quite a few research communities. I started off as an integrated circuit designer and moved through network sensors, and now I am building mobile applications in the developing world.
And I'm Luis Sazzi. I was born and raised in São Paulo, Brazil. I haven't been at UW quite as long as Gaetano. About 20 years later, I started at UW, and I got my PhD at the University of Illinois, and I did work on computer architecture and compilers, and now I still do work in those areas, as well as I do energy efficiency. So Brazil is known for beaches, and I love going to the beach. However, Brazil is also known for soccer, but I do not like soccer, so don't talk to me about soccer. I don't know anything about it.
Okay, we also wanted to show you where we work. That's the Paul G. Allen Center for Computer Science and Engineering at the University of Washington, and it's a gorgeous building with a beautiful 6-story high atrium. And we are also known for the cherry blossoms on our campus, which just recently bloomed this March, and our mascot, the husky. Lastly, we're also known for Mount Rainier and some of the gorgeous mountain views around campus.
Who are you? So there are literally thousands of you, and so that means that we don't get to know you face to face, which is too bad. But please do fill our online forms so we get to know a few things about you, and we're going to report aggregate statistics so we all know who you all are.
All right, so what is this class about? It has an interesting title, the Hardware-Software Interface. And so what is hardware and what is software, and what do we need to understand about this interface in between? So hardware, of course, is the physical hardware, the chips that run the instructions that make all of our modern computing systems possible. Software is the code that we take through a series of steps and compile down to the basic instructions that that hardware knows how to execute. And what this class is about is how do we get from those high-level languages down to the primitive instructions that are present in our hardware processors. That's what the hardware-software interface is about.
So we expect to know some things, for example, basics of binary numbers. So you have an example. We have two numbers, both base 2, so they're both binary numbers. And say if you're trying to add 1001 with 0001, you get 1010. We also expect you to know binary logic operators like AND, OR, and NOT. For example, A and B. A and B is true if and only if A is true and B is true and false otherwise. Okay? We also expect you to know introductory programming in Java or C would be even better. And none of the fancy stuff, just if statements, loops, and procedures and methods would be enough. We also expect you to have access to a modern personal computer so you can run the tools required to run the assignments in this class.
Okay, so what are the outcomes of this course? As Luis said, we just expect you to have some of the basics of computer programming. Nothing too fancy. Most of our students here at UW know Java, but other languages are probably just as good. We are going to take you into this class to help you understand those abstractions that exist between those programs and that hardware that they run on. But not only what those abstractions are, but why they exist and how they build upon each other. That's really the important aspect of this course. And to do that, we're going to take you through some of the implementation details of these underlying abstractions. The hope here is that this will make you more effective programmers, able to understand the many factors that influence a program's correctness and performance. So in the end, we hope you'll be much better set up for following on to future classes in computing with a good solid foundation for how this stuff really comes together.
And to achieve the outcomes that Gaetano just told you, here's what we're going to have you do. You're going to have 5 programming assignments, one every 1 to 2 weeks. And we're also going to recommend pencil and paper problems for your own benefit. and we're going to point you to relevant sections of the book. So we are, that said, we really want to make the lecture self-contained and review the textbook mainly as supplementary material for a second point of view, but we do expect you to read them.
Okay, so about those reference texts, and again, these are purely recommended. They're not required by any means, but you might find them helpful. The first is the Computer Systems text by Bryant and O'Halloran. This is a great book that the second edition came out just a few years ago, and you can get it from lots of different places. The book also has an extensive website at CMU. And we also would like you to have a reference for the C programming language, which we'll be using in this class. Now, there's lots of options here. We have a few recommendations here on this slide, but really anything will do, and there's lots of info even available on the web if you don't want to bother purchasing a text.
It takes a lot of work to put a class together, and this class is no exception. So there's a lot of people that were behind in making this course happen. First, the TAs that work behind the scenes, and as well as the previous Coursera instructors at UW who taught us about all of the things that we should and should not do when teaching this class. And this class actually being taught, this version of this class is being taught in many places, and including CMU, where the authors of the book that we just talked about are like Randy Bryant and David O'Halloran and other instructors at CMU. And Matt Welsh used to be at Harvard and now at Google Seattle also taught this class and gave us a lot of material and feedback, and instructors at UW like Peter Horniak, Hal Perkins, and John Zahorian.
All right, so thank you, and we look forward to having you in the class.
Definitely. See you soon.
Bye-bye.
Bye.